Hello class, in today's video we're going to be looking at simple interest. The learning intention of today's video is we're going to develop an understanding of simple interest. We're going to learn how to calculate the simple interest and balance using the explicit formula. And lastly, we're going to be learning how to model simple interest problems using recurrence relationships. Now, I'm hoping that you guys already have a really good understanding of simple interest from your Maths A subject, but I'm just going to quickly review a bit of simple interest so that you can consolidate and strengthen your understanding. We said that simple interest is a special type of interest that you can either earn or charge depending on the context if you're either borrowing or investing, and this is always going to be based on the principal, which is referred to as the original amount, okay? Now, the amount of interest that you earned through simple interest is always going to be fixed or constant each single time. So as you can see by my graph on the right hand side of here, notice that you're always going to be increasing by the same rate, which in this example over here is going to be $50 for every year. Now, in our previous lessons, we've looked at arithmetic sequences, and what I'm going to show you now is how is arithmetic sequences, the things that we've learned in the previous lessons, related to our new topic today, which is related to simple interest. Now, if you were to represent arithmetic sequences, meaning that if you were to plot each single term in the arithmetic sequence, what you'll get is you're going to produce a linear graph. And we know that the balance that's earned or charged through simple interest will also follow this same trend as well. So in this case, in my example on the right hand side, this is a graph that models arithmetic sequences. We know that to get to the next term over here, we just add it by the common difference, okay? And notice that it kind of increases by the same amount, which is why you would actually produce a straight line. As I've shown you in the previous slide, the balance for a simple interest account will also follow the exact same trend as well. Now, in order for us to calculate the balance of our loan or our investment account, we can do this in two ways, okay? We can do this by using recursive relations, also known as the long method in this case over here, or this could also be done in the explicit formula as well. So this is kind of related to arithmetic sequences, guys. So and I wanted to let you know that in Maths A, we've already been exposed to the explicit formula, and using the explicit formula, this helps us to calculate the balance as well as the simple interest earned quite efficiently. But what we haven't looked at so far is how do we actually express this or model this using recursive relations. Now, if you guys remember from our previous lessons, to do something recursively means to do it the long way. It's repeating in this case, and you're going to be repeating a single step to get all the other values in the sequence, okay? And that's what we're going to be focusing predominantly in today's lesson. So I'm just going to quickly give a very brief overview of how we could actually use the explicit formula, because I am quite confident that you already retain most of this knowledge from your Maths A subject. So remember that if you were to use the explicit formula, these are the two formulas that you could be using to calculate simple interest. Both of these formulas are pretty much identical. The only fundamental difference is that one of them has a capital R, whereas the other one has a lowercase r. Capital R in this case, if you were to use this particular formula over here, you would actually need to convert the interest rate into a decimal. So for instance, if it was 15%, then you would actually substitute 0.15 because that's the decimal form of that. Whereas if you were to use this formula over here, you would just substitute 15 directly into this formula. You do not need to do any conversion whatsoever. But I personally recommend that you use the formula on the right hand side because you're going to make less errors. There's less chance of you making an error. So please try to use this second formula, but if you're used to using the first formula, go ham with it. And once you actually find out what your interest is, then you can actually find out what is the total amount in your balance. So this over here, this formula over here calculates the total amount, which is represented by the capital A. But using the simple interest formula, we can kind of rearrange or transpose the formula in such a way that we can actually calculate the values of the other variables. So we can calculate the principal, the interest rate, as well as time. So we have got the flexibility to find these. And if you don't have this in your exercise book in your Maths A subject, or then I highly recommend that you please copy these formulas down. Now, I'm not going to go through any examples of how we could actually use any of these formulas to calculate the total balance or to calculate the interest earned or to calculate the time period, because this is kind of done already in your Maths A course. So if you do need extra assistance, then I highly recommend that you watch my previous video to calculate simple interest, which can be found in this link down below. So please watch these videos over here if you need assistance. Otherwise, we're going to continue on with the next topic of today's lesson. So what I'm going to show you now is pretty much something new and that you haven't actually learned yet in Maths A. And what we're going to be doing is we're going to be modeling simple interest accounts via recurrence relationships, okay? As you can see from this slide over here, this is a slide that I pretty much copied and pasted from our very first lesson about number sequences. And in order to do something recursively, remember the word recursive or recurring means repeating. And in order to find all the other terms in the arithmetic sequence, we just need to keep on repeating by adding by the common difference. And that's what this general formula shows over here. So in this case of here, we know that the first term is 3. And in order to get all the other terms, we just add it by the common difference, which is 7, and therefore to represent this in a recurrence relationship, this is going to be our answer. Now, how is this going to apply for simple interest? We're going to be using a very similar formula to actually represent or model simple interest problems, okay? So we're going to be using different letters in this case. So instead of using the letter T, we're going to be using the letter V. And what V0 represents is this represents your principal amount. So for instance, if it tells you that you're investing in $500, then V0 would therefore V0, which is your principal, is going to equal to 500, okay? So just please remember that V0 equals to principal. Now, what this word or this term over here means is this just represents what is your final balance after this year or so. So for instance, if you wanted to find out what is your final balance after, let's say 10 years, okay, what you need to know is that you need to know what is the amount that you had in the 9th year and just add it by the interest that's being earned or charged in this case, okay? And to do that, all we need to do is just multiply the interest rate by the principal. So that's how you would actually use this particular recurrence relations. Now, this might be quite overwhelming, but I can assure you, once I go through one example with you guys, you'll find that this is going to be quite easy to do, okay? So please copy the notes down on this particular slide, and then we'll continue on looking at an example. So I've got an example on this slide over here, and it reads, John invests $7,000 in an investment account that pays 3.2% per annum for simple interest. The first part of the question wants us to use the recurrence relations to find the value of the investment after 1, 2, 3, 4, and 5 years. Now, you're not, if you were to use the explicit formula, you're actually not going to get any marks at all because the question specifically wants you to use the recurrence relations. And to use the recurrence relations, remember, this was like the general formula over here. So let's use this to actually solve the problem. So in this case over here, let's interpret the question. What is your principal amount? Well, in this case over here, your principal amount is going to be 7,000. So I'm going to write your V0 is going to equal to 7,000 because remember, your V0 represents the principal. And we know that your interest rate is going to be 3.2% per annum, meaning 3.2% per year. So let's first find out how much interest are you being charged every single year. So let's find out what day is going to be. So if you do this, 3.2 divided by 100 is equal times 7,000 is going to equal to 224. So for every single year, you're going to earn an additional $224 in your account, okay? Now, the question wants you to find the value of the balance, the final account balance after 1, 2, 3, 4, 5 years using this recursive relation. So all we're doing is just going to be repeating, all we're going to be doing is we're going to be constantly adding by the simple interest to actually obtain our final balances. So this is what it would look like, for instance. We know that to calculate V1, you need to know the value of your initial value plus by your interest rate. So therefore, all I do is go V1 is equal to 7,000 plus 224. So therefore, at the end of the first year, I'm going to have 7,224 in my balance. To find out the second year, all I really need to do is use this formula here. V2 is equal to V1 plus D, which in this case is equal to 224. So if I apply that formula, then this is what I'm going to get. So as I said, remember, recursive relations, we're just going to be adding by the same amount every single time. So if you do this for the other values, then this is what you guys are going to be getting, okay? And lastly, for part B of this example, it says, when will John's investment first exceed $8,000 and what will its value be then? Now, based on your answer in part A, we can easily see that after 5 years, you'll earn an amount that exceeds 8,000. So the way that I'd answer is, after 5 years, John investments will exceed $8,000 and its value will now be equal to $8,120. So after this example over here, I'm pretty confident that you guys should be able to tackle any questions that ask you to model simple interest problems using recursive relations. So I'm going to get you to now have a go at answering this question over here. Give yourself about 5-10 minutes. Please pause this video and answer part A, part B, as well as part C. If you guys did this successfully, then this is what you should be getting for your answer for part A. Now, I'm just putting the information into a table format. You don't have to, but it just looks a bit more organized and neater. So in this case over here, I'm going to be showing you my calculations, or the formula that I'm using to calculate the amount after the first year. Okay, so in this case over here, it's already given us the recursive relations formula. All we're going to be doing is just using this to answer the question. So to calculate the amount I have in the first year, it's going to be 2,000 plus 76, guys, because remember 76 in this case is going to be equal to our interest rate. So they've already did the calculations for you, because if you did 3.8 over 100 multiplied by 2,000, this should equal to $76. So in this case, the amount you have in the first year is going to be equal to $2,076. To calculate what you have for the second year, all you do is just add 2,076, the amount you earn in the first year, plus the interest rate, because the interest is always going to be constant. If you do this, it's going to equal to 2,152. And for the same thing for the amount in the third year, it should equal to $2,228. And I'm pretty confident that you should be able to get these answers correctly. Now for part B, we want you to use a calculator to determine how many years it takes for the value of the investment to be more than $3,000. So what you're doing really is just using trial and error. See how long you have to keep repeating this until you get a value that is greater than 3,000. And if you did this correctly, then it should be for 10 years. I don't have the working out over here. And to answer part C, which says write down a recurrence relation model if 1,500 was invested at the rate of 6% per annum. So in this case over here, instead of having $2,000 as your investment, you're now going to have 1,500 with an interest rate of 6,000. So we need to express it in a similar manner to this. Okay, so I've already provided you this information over here just so that you can refer to. So for instance, what we need to do first is state what your V0 is going to be. So your V0 is going to equal to 1,500. Now in order to write it in a similar manner to this, I need to find out what my interest rate is going to be, or my interest earned. So I need to find what capital D is equal to. So in this case, your interest rate is now equal to 6%. So it'll be 6 on 100 multiplied by 1,500. And if you did this, therefore your recursive relation model will therefore be this: Vn plus 1 is equal to Vn plus 90, where 90 is equal to the interest earned. All right, guys, what I'd like you to do right now is I'd like you to answer these two questions over here. So please have a go answering these two questions. And if you did this correctly, then these are the answers that you should be getting. Try to use full working out when you're solving these problems. But I also want you to answer these questions over here. When you're answering these questions, okay, class. Okay, class, what I'd like you to do now is I'd like you to have some practice of actually representing or modeling these simple interest problems using the recursive relations formula. So have a go answering these two questions. Try to show full working out for these two questions. And if you did this successfully, then these are the answers that you should be getting for these questions over here. And what I also like you to do is I also like you to answer these 6 questions over here. But for these 6 questions, I want you to be using the explicit formula. So using the very short the quick easy formulas that we've learned in Maths A to actually solve these problems. This is the end of today's video. Hopefully this video helped you. I'll see you guys again in the next video. Bye.